Math 3, Unit 5, Section A. Okay, so today we are talking about equivalent rational expressions and basically reducing rational expressions. One thing is that we always want to reduce to lowest terms. Anytime you have like a plus or a minus, everything has to be the same in order for you to cancel it out. But if you notice, like on A, there isn't a plus or minus, so you can reduce your numbers and your letters. Okay. Another thing that you need to think about is extraneous solutions or excluded values. So in a fraction, anytime you have what in the denominator, we'll make it undefined. A 0. So we can get rid of radicals in the denominator. But basically, if you have a 0 in the denominator, and so if you look right here, when the denominator is 0, that answer will not work. So for every single one of these fractions, we need to also state what would make it not work. So we call those extraneous solutions or excluded values. So for instance, on A, the only value that would end up making this not work would be if A equaled 0. Because if A was 0, then the denominator would be a 0. Does that make sense? And so we're just going to end up writing A cannot equal 0. And then we're going to simplify it. So can the numbers reduce? Yes. So 7 goes into 21 3 times. And then what happens with the A's? Good, you subtract the exponents, right? So the 2 on top cancel out, and you're just left with an A on the bottom. Is everybody okay with that? If you weren't sure, just real quick, that we had A times A on the top, and there was 3 A's on the bottom, so you can cancel out 1 for 1, and we're left with 1 on the bottom. And so my answer is 3 over A. So basically, there's 2 portions of the answer, what your excluded values are, and then also the simplified form. Okay, so right now on B, how could we figure out what would make the denominator 0? And if you're ever not sure, all you have to do is take your denominator and set it equal to 0. So I'm just going to kind of do this here. So I'm going to put 4D plus 8 equals 0. And if we were to solve that, we would subtract 8. 4D equals negative 8. And then I would do what? Divide by 4. And so D cannot equal what value? Negative 2. Okay, at this point right here, there's nothing I can reduce, but do we notice anything that we could do in order to make things reduce? So like I said, anytime there's a plus or minus, everything has to be exactly the same in order to cancel it. But is there a GCF there or something that I could factor out on the bottom? What could I take out? Or even a 4. So I could factor out a 4, and I'm left with D plus 2, and on the top I still have 18D squared. Now that I've done that, can anything reduce? Good, the 4 and the 18. So what number goes into both 4 and 18? 2. So that can reduce to a 2, and this can reduce to a 9. And that looks like that's all I can do. So my answer is 9D squared over 2 parentheses D plus 2.
So when you take the GCF, is it only one on top or the bottom, not both?
Correct. So you think of those almost like separate problems, and then if they have anything in like, then we can cancel them out. Okay, so far so good? All right, so on C, the first thing again we want to look at is our denominator and what could end up making that equal to 0, because that cannot be an answer. And so if we're ever not sure, like in this case, what do we do? Good, just set it equal to 0. So I'm going to write 6n minus 9 equals 0, and then we're going to solve. So we add 9 to both sides. 6n equals 9. And then we divide by 6 to both sides, and we can reduce. And so n cannot equal what? What could that reduce by?
3 over 2.
Good. So it's going to be 3 over 2. Okay, is there a GCF? Is there anything I can factor out on the top here? No. So we still just have 2n minus 3. And in the denominator, is there a GCF or something I can take out? What? A 3. And so when I take out a 3, what am I left with?
2n minus 3.
Good, 2n minus 3. And so these both end up canceling. If there is nothing on top, what's actually here? Good. And so this answer ends up becoming 1 over 3. Okay, any questions? All right. So moving on to the next one. If we set this equal to 0, 2c squared plus 7 equals 0. We would subtract 7 to both sides. 2c squared equals negative 7. I divide by 2. In order to get c by itself, what would I end up doing now? Okay, but can I take a square root of a negative number? No. And so there basically is not a value that will end up making this equal to 0 in the denominator. So there's no excluded values. Okay, so if you think about it, if you were to put a negative number here, like negative 3. Negative 3 squared will make a positive 9. So there's nothing that will make this part negative to end up making the plus 7 make it 0. Does that make sense? Okay, so then we need to figure out, can I factor anything out? So I notice for sure I can take out a c. Okay, now I always look at like one of the numbers. And so if I were to break 26 down, what two numbers multiply to be 26? 2 and 13. So then I check, okay, is 91 divisible by 13? And if you plug it into your calculator even and just go 91 divided by 13, the answer is 7. Okay, so on the top there's a GCF of what? 13, and also how many C's? 1 C. So 13C. And what am I left with? Good. 2C squared plus 7. And this is over 2C squared plus 7. And so notice that these are exactly the same, so that means I can cancel them out, and my answer is 13C. All right, moving on to E. So again, we need to focus on our denominator first. And so my denominator, if I take x squared minus 2x minus 8 equals 0, what would I do to that problem? Factor it. Good. So since I have an x squared term and an x term, we need a factor. So remember that is my adding number, and this number is my multiplying. And so what numbers multiply to be negative 8 and add to be negative 2? Good. X minus 4 and x minus 2. And when I set those equal to 0, what do they equal? 4 and 2. So that means that x cannot equal 4 or negative 2. Good. Okay, so next, is there anything on the top there that I can take out? Good, it has a GCF of 2. So I can factor out a 2, and I'm left with, good. And then my denominator I've already factored, and it is x minus 4 and x plus 2. So is there anything that can reduce? Good, the x minus 4s. And so I'm left with 2 over x plus 2. Can I cancel out these 2's? No, because they are connected. This 2 is connected with a x. So in order to cancel it, you'd have to have an x and a 2 being added together. So anytime you're adding or subtracting, the only way to cancel them is if everything's the same, like the x minus 4s. So there's my answer. Okay, F, what am I going to do first? Good, set our denominator equal to 0 to figure out our excluded values. When I do that, what would I do to solve now? Since there's just a plain A, what would I do? Good, add 3 to both sides. We have 3A equals 3. My next step would be to, good, divide by 3. And so A cannot equal what? 1. And again, what is the reason? Why can't A equal 1? What will happen? Good. It'll end up, if A equals 0, it'll give you a 0 in the denominator, which will then make A undefined problem, okay? So that's why A cannot equal 1. All right, so on the top, can I factor this? Is there anything that adds to be negative 3 and multiplies to be 2? 1 and 2, and specifically negative 1 and negative 2, right? So those multiply to make a positive 2, and you add them together and they make a negative 3. Okay, in the denominator, is there something I can factor out? Good. And I'm left with A minus 1. And my A minus 1s can cancel, and so my answer is A minus 2 over 3. Okay, G. Okay, the first thing I should start with is what? Good, set your denominator equal to 0. So we have 2z squared plus 7z plus 6. Do you guys remember how to factor that one? Good. Start by multiplying 2 times 6, which is 12. So my multiplying number is 12, and my adding number is 7. So what numbers? Good. 4 and 3. So remember when we rewrite this, we keep the 2z squared, but we change 7z to be what? Good. 4z and 3z, and then we keep our plus 6. Okay? Do you guys remember that? Okay, and then at this point, how do I factor it? Good, grouping. We take out our GCF of each group. And so my first group here, what's my GCF? 2z. And I'm left with z plus 2. My second group, what's my GCF? 3. And I'm left with? Good. And so how does this end up factoring? What do you do next? Good. So your GCF is really the z plus 2. So one of your parentheses is z plus 2. And then your other parenthesis is whatever is left. And so that is 2z plus 3. And when we set those equal to 0, what can z not equal? So if you set z plus 2 equal to 0, z would equal what? Negative 2. And then when you put 2z plus 3 equal to 0, what does that make? Good. Negative 3 over 2, or negative 3 halves. Okay, so z cannot equal these two things.
How'd you get negative 3 over 2?
So if you take 2z plus 3 equals 0, you would have to subtract 3 first. And then you have 2z equals negative 3, and then you divide by 2 to get negative 3 over 2. So in my head, you know, I always take this number, and I know it's the opposite, and then the other number would be on the bottom. Okay. So back up to the original problem. What would I factor out first here on the top? 6. And we're left with? Z plus 2, good. And then the denominator we know will be what? Good. And so my z plus 2's can cancel. And we are left with 6 over 2z plus 3. And can anything there reduce? No. Good, because anything that's connected with a plus or minus, you can't cancel unless everything's the same. Okay? All right, I'm going to give you guys a minute to try H on your own. If you get the answer, raise your hand and I will come and check it.
Kevin's gonna.
What are the excluded values? No, 5 o'clock mass.
Okay, so to start with, what were the excluded values? Good, -2, -3 are correct. And so we would find that by setting our denominator equal to 0. So I normally always start with this so that I don't forget to do it. And so we're looking for what adds to be 5 and multiplies to be 6. 3 and 2. C plus 3, C plus 2 equals 0. So that means C cannot equal -3 or -2. So when we go up to the top here now, this one we are looking for what adds to be -1 and multiplies to be -6. Good, C minus 3 and C plus 2. We already factored the bottom, which is C plus 3 and C plus 2. And so these can cancel out, and we're left with C minus 3 over C plus 3. Any questions? Okay, we're going to move on to the back side. Okay, and a lot of this you kind of learned back in Algebra 1, but for some reason this concept is one that is sometimes confusing. Sometimes the numerator and denominator are opposites. So if we look up here, We have x minus 3 and 3 minus x. Those are opposites. And to simplify this expression, basically what you can do is you can take negative 1 from 3 minus x to get negative 1 in the front, and then it becomes negative 3 plus x. Do you see how negative 3 plus x now is the same as x minus 3? So you can end up changing the order, and so you end up with x minus 3. Okay, and so that's all you have to do. So if you notice they're opposites, you just need to take negative 1 out from one of the equations. Okay, so, but the first thing that we always need to look at is what? Your denominator, and if it has any extraneous solutions or excluded values. So if I take 5 minus 2x and I set that equal to 0, I'm going to add 2x to both sides. If you subtracted 5, you're going to end up with the same answer. So we get 5 equals 2x, and then I divide by 2, and so x cannot equal 5 over 2. Okay, and at the top, in order to make it so, because these are opposites right now, we would end up taking a negative 1 out from the denominator, which would make the 5 a negative and the 2x a positive. And then if you want to rewrite it, I can rewrite this keeping the 2x minus 5 in the numerator. And then the denominator is negative 1, and then we can flip that around to be 2x minus 5. So now that these are the same, they cancel out. If you have 1 over negative 1, that answer is just what? Negative 1. Okay, what would be your excluded values for j? If you went 4 minus y equal to 0, what would we do? Add y to both sides. And so we get 4 equals y. So that means that y cannot equal 4. Okay. On the top, is this factorable? What is a factor to be? Good. Y minus 4, y plus 4. And then what would I need to do in the denominator? Good. Take out a negative 1. And so when I do that, that makes the 4 negative and the y positive. And so we have negative 1 parenthesis y minus 4. Can anything cancel? The y minus 4s, right? Okay. And so that means that I have a y plus 4 over negative 1. But how would I write that? Can you just go ahead? Yeah. So you can just have that even as a negative and then parenthesis y plus 4. The negative can really go at the top or the bottom. If you were to distribute this, though, it would be negative y minus 4. And you can leave it as the negative in the front. Just keep that in parentheses. Questions? Okay, Kay, what will I need to do first? Good, set your denominator equal to 0, right? Because we need to find out any excluded values. So 6d squared plus d minus 1 equals 0. What will I do next to factor this one? You want multiply 6 and 1, right?
Negative 6.
Very good. And that makes what? A negative 6. So we're multiplying to be negative 6. And what adds to be 1? So what numbers work? Good. A positive 3 and a negative 2. Are we okay with that? So then how do I rewrite this?
60 squared plus 3
Good. Okay, and so then to factor this, we break it up. So we have our grouping. And so what can I take out of my first group?
3D.
Good. 3D, and I'm left with, good. In my second group, what will I take out?
Negative 1.
Good. A -1, and I'm left with,
2D plus
and so that ends up factoring to be what?
2 plus 1, 3 minus 2.
Good. 2D plus 1 and 3D minus 1. Okay, when we set those equal to 0, what can D not equal? Nope, they, okay, positive 1/3, and then -1/2. Are we good with that? Okay.
Why is it -1/2?
Because on this one, the positive one, we'd move it to the other side, which would make it a -1,
Oh, okay.
and then divide by 2. Okay, so going back up here, if my denominator is 2D plus 1 and 3D minus 1, I notice for sure here, what could I do on the top? Okay, so if I take out a 3, I'm left with 1 minus 3D. So what more would I need to do? Right, we want to take out a -1 or a -3. So if I take out a negative, the 1 becomes a negative and the 3D becomes a positive. So I'm going to rewrite this as -3, parenthesis, and then 3D minus 1. Is everybody okay? Yes? Okay. So 3D minus 1's cancel, and we're left with -3 over 2D plus 1. Okay, last one for today. What would I do first?
So the denominator equals 0.
Good, denominator equal to 0. So we have 2z squared minus 2 equals 0. What would you do to solve this one?
It's not gonna have like an extraneous solution because it's squared.
Actually, this one will. It's when it'll equal a negative. 2z squared equals 2, and then what? Divide by 2 to both sides. We have z squared equals 1, and so what would I do now? Square root. Now, what is the square root of 1? It's actually positive or -1. Remember that anytime you make a square root, the answer will be positive or negative. And so there are 2 excluded values, +1 and -1. Oh, and I meant z cannot equal that. All right, so back up to the top. Can I do anything on the top here? 3, and I'm left with? Good. Okay, the denominator. What can I do? Take out a 2, and we'll have z squared minus 1. Okay, can the denominator be factored further? To what? Good, difference of squares. Z minus 1, z plus 1. Now, what would I need to do on the top to make it so they can cancel? Good. Take out a negative, and that would make the -1 and a positive z. So when I rewrite that, I have -3 z minus 1. The z's minus 1's cancel, and so we're left with -3 over 2 parentheses z plus 1. Any questions?